Okay, so today we will teach you about chapter 8, correlation and regression. The correlation coefficient is a statistics which provides the information on how strong the relationships between two variables is. While regression analysis is a statistical technique which can be used to obtain the equation relating the two variables. For scatter diagram, graphical technique used to show the relationship between variables. The following diagrams show the various relationship between two variables. Okay, this is positive and linear graph. This is negative and linear graph. This is negative non-linear graph, while this is no relationship graph. Covariance is a measure on how much the variables of x and y vary together. This is the formula for covariance. Okay, now I show the solution for the question example 8.02 in textbooks page 195. Okay, firstly you must find the total number, which is n equal to 5, the x bar 0.25 and y 20.5. And then to find the covariance, you must find SSXY first using the formula total number of x and y minus total x multiply with total y and divide it with the total number, which is 5, and you will get the answer 15.2060. Okay, then to find the covariance xy, we must divide SSXY divide with n minus 1, which is 4, and we will get the answer 3.8015. Okay, this is the solution for this question. Okay, coefficient of linear correlation measured the strength of linear relationship between two variables, which is independent and dependent variables. The coefficient of linear correlation standardizes the measure of dependency and allows us to compare the relative strengths of dependency of different sets of data, also commonly called Pearson's product moment, which is R. So here is the formula for R. How to interpret a correlation coefficient value? The value of a correlation coefficient ranges between -1 and +1. A coefficient of +1 indicates a perfect positive correlation, which is a change in the value of one variable will predict a change in the same direction in the second variable. A coefficient of -1 indicates a perfect negative correlation, which is a change in the value of one variable predicts a change in the opposite direction in the second variable. So you can see here there are positive correlation, negative correlation, and also no correlation. Okay, the solution for example 8.05 page 199 in textbook. Get total x. You will find total y, total x square, total y square, and total xy. Firstly, you must find SSXY. As we know, the formula is total xy minus total x multiply with total y and divide with n. We'll got the answer 7.2857. And then we must find SSX, total x square minus total x multiply with total x and divide it with 7, and we'll get the answer 10.8571. And then find SSY, total y square minus total y multiply with total y and divide it with 7. Here we got the answer 7.4286. Then you must find R, SSXY, divide with square root SSX multiply with SSY. We will got the answer 0.8110. Regression analysis. Line of best fit results from an analysis of two related variables. Try to predict the value of the dependent or output variable. The variable we control is the independent or input variable. This equation represents the simple linear relationship between the two variables in a position where beta naught, the y-intercept, estimated by b naught, beta 1, the slope, estimated by b1. Omega is experimental error, estimated by E, equal to y minus y cap. Experimental error. Errors that may occur in execution of statistical experimental design. Types of experimental error include human error or mistakes in data entry, systematic error or mistakes in the design of the experiment itself, or random error caused by environmental conditions or other unpredictable factors. Experiment design seeks to minimize experimental error in order to produce the most accurate data possible. Formula for experimental error: writing SE square equal to total y minus y cap square divided by n minus 2. And then the final answer you will get SSE, which is sum of squares for error per n minus 2. So the solution for this question is by using SSX equal total x square minus total x square over n. And then we got the answer 608.9. Then find SXXY equal to total xy minus total x multiplied with total y over n. And then you will get the answer 4378.9. Then find b1, which is SSXY over SSX. And then you will got the answer 7.1915. And then find b naught, which is total y minus b1 multiply with total x over n. You got the answer. $39.8105. Let's find variance of y. To find variance of y, you must use the formula SE square equal to total y square minus B naught multiply with total y minus B1 multiply with total xy over n minus 2. And then we'll got the answer 1341.8244. This is the illustration for scatter diagram, regression line and random errors. Precautions. First, the regression equation is meaningful only in the domain of the x variable studied. Estimation outside this domain is risky. It assumes the relationships between x and y is the same outside of the domain of the sample data. Second, the result of the one sample should not be used to make inferences about a population other than the one from which the sample was drawn. Third, correlation or association does not imply causation. A significant regression does not imply x causes y to change. Most common problem is missing or third or variable effect.